integration of trig functions doesn't work the same way as the antiderivative when you are reversing the power rule from differential calculus. Instead, what it relies on are over here, the derivative of sine x is cosine x, the derivative of cosine x is minus sine x, the derivative of tangent x is secant squared x, the derivative of secant x is tangent x secant x, the derivative of cosecant is minus cosecant cotangent, and the derivative of cotangent is minus cosecant squared. My video on how to find the derivatives of these trig functions and how they're derived is linked at the end of this video. So if I'm asked to integrate cosine x dx, it's asking to reverse this from when you took the derivative, and I see that cosine x is the derivative of sine x, so reversing this is simply sine x plus c. Now, if you were asked to find the integral of minus cosine x, this is a minus 1 in front of here. So you bring the minus 1 to the front, and then you repeat what we just did in the last step, which was just cosine x dx. So this would be minus 1 times sine x plus c. And if we're asked to integrate minus sine x dx, we look over here. Minus sine x is the derivative of cosine x. So the answer for this one is cosine x plus c. Here we're asked to integrate 7 sine x dx. And there's no minus sign in front, but we would put that back on the next step. So I move the 7 to the other side, and then I'm going to get the integral of sine x dx. So when I integrate this, I'm going to have to, instead of it being cosine x, it's going to be minus sine x, and I bring the 7 to the front. So minus 7 cosine x plus c. From here on, they're pretty intuitive. So on this one, move the 4 to the front. And then we see the integral for secant squared x is tangent x. So we rewrite it. Then we add the constant. When we integrate tan x secant x dx, we get secant x plus c. Here we have, it's almost in the right form here. It has the 5, so we move the 5 to the front. And then from this basic form, we have 5 cosecant x plus c. Here we're asked to integrate minus cosecant squared x dx, and we see that that is the derivative of cotangent x. So next line, cotangent x plus c. Now that we're done with the basic 6, what we have here is something that doesn't exactly translate into something that's over here, but it's going to use pieces of this. And what I have to do is I have to discover how I arrive at this fraction. And one way that we can look at it is if we can break this into 2 different fractions that are being multiplied by each other. So to get sine of x, one of them would have to be sine x, and the other would have to be the number 1. And to get cosine squared x, I would put cosine x here and cosine x here. Well, when I'm looking at this, a bell should be going off specifically on this one over here, because if I have sine x over cosine x, this is a trig identity, which is equal to tangent x. So I'm just going to write tan x here times, and then 1 over cosine x is secant x. So in the form that we have this here, tan x secant x, if I go over here, I see tangent x secant x, and that is the derivative of secant x. So the integral of this is secant x plus c. With this problem, there's a couple of points that I want to make with it. First is when something's separated by a plus or a minus, you're going to treat that as two separate problems. And the other thing is, notice that this is not secant squared x, it's secant squared theta, and this derivative was taken with respect to theta. So when you integrate, theta is going to be in your answer instead of the x. So first, the integral of secant squared theta, as we see over here, is tangent theta. So I put tan theta. And then the minus sign is the derivative of cosine, so this is going to be plus cosine theta. And then we're going to add a c because we don't know if there was a constant. In this problem, we have 1 minus cosecant t, cotangent t, dt. So this 1 over here was the coefficient in front of a t, because this is a derivative in terms of t. So this is simply t. And then minus cosecant t, cotangent t is the derivative of cosecant t. So this is plus cosecant t plus c. When you're doing integration of trig functions, there are some trig identities which are going to be pretty common. So let's review a few of them here. So the first one is sine squared x plus cosine squared x equals 1. And then if I subtract sine squared x from both sides, I'm going to get cosine squared x equals 1 minus sine squared x. And if I was to subtract cosine squared x from both sides, I would get sine squared x equals 1 minus cosine squared x. A few others that are common. So you have 1 plus tangent squared x equals secant squared x. And 1 plus cotangent squared x equals cosecant squared x. Next, we're going to talk about the reciprocal identities. So the reciprocal of sine of x is cosecant x. 1 over cosine x is secant x. Next one is 1 over tangent x is cotangent x. We've actually covered them all because the reciprocals of all of these will give you this back. So 1 over cosecant x is sine x. 1 over secant x is cosine x. And 1 over cotangent is tangent x. And last up for this video, we're going to talk about the quotient identities. Sine x over cosine x is equal to tangent x. And its reciprocal, cosine x over sine x, is equal to the reciprocal of tangent, which is cotangent x. Well, for this practice problem over here, there are two ways of doing this that jump right out at me. And the first one, which is really simple, I see on the top here that we have a trig identity that we just reviewed, sine squared x plus cosine squared x equals 1. So on the next line, I can replace the sine squared x plus cosine squared x with 1. Now from here, we just reviewed the reciprocal identities, and 1 over cosine squared x is secant squared x. And we see over here that secant squared x is the derivative of tangent x, so taking the integral of secant squared x is simply tangent x plus c. Another way of doing this one is to split this into two fractions. Both of them have the denominator of cosine squared x. Doing it this way, we see that we have sine squared x over cosine squared x, and we just reviewed the trig identity of sine x over cosine x is equal to tangent x. So this whole part over here is tangent squared x. And of course, on this side over here, we have cosine squared x over itself. So this whole thing is 1. And tangent squared x plus 1 is a Pythagorean identity that equals secant squared x. And same as before, secant squared x is the derivative of tangent x. So the answer for this one, the integral is tan x plus c. Don't get nervous about the trig identities. If you just keep doing practice problems, you'll eventually memorize them, and then you'll spot them, and a bell will go off every time you see one.